You open TikTok for the first time. You have no history, no account linked to anything, no stated preferences. You watch a few videos, you scroll past a few more. Within 30 minutes, the app knows things about you that your closest friends took years to learn. Your political lean, your sense of humor, a particular flavor of late-night anxiety you carry and have never described to anyone. This is not magic, and it is not surveillance in the way people usually mean that word. This is machine learning operating at a scale and speed that is genuinely difficult to comprehend. Today we are going to open the black box and show you exactly how it works, from the raw signals the app collects every second you are watching, to the deep neural ranking models that convert those signals into something that feels unsettlingly like the app already knows you better than you know yourself. Before we get into the algorithm, let us clear up the most common misconception people have about how this works. TikTok does not learn your personality because it reads your mind, and the good news is that it does not need to. It reads your behavior instead. Every second you spend on the app, you are transmitting signals, and those signals taken together paint a portrait of you that is statistically more accurate than any personality questionnaire you would fill out yourself. The reason for that is simple and has been validated repeatedly in research. Self-reported preferences are fundamentally unreliable. People say they prefer educational content and then spend 3 hours watching absurd comedy. The algorithm does not ask what you like. It watches what you actually do, and it trusts that behavioral record completely over anything you might say about yourself. The most important signal TikTok collects is watch time, and it is measured to the millisecond rather than in coarse buckets. Not whether you liked a video, not whether you shared it, but how many seconds of it you actually consumed in that viewing session. Did you watch to the very end? Did you replay it immediately without even scrolling? Did you pause at a specific frame and then rewind a few seconds? A 3-second watch on a 15-second video tells the system something completely different from a 45-second watch on a 60-second video. Alongside raw watch time, completion rate is tracked as a ratio independent of video length. Positive interaction signals are also logged. Likes, comments, shares, follows, saves, and profile visits, each weighted differently because they represent meaningfully different levels of intentional engagement with the content. And critically, negative signals are treated as first-class training data, not as edge cases to be discarded. When you tap not interested, scroll past in under a second, or explicitly report content, that data is just as informative as a like. The system learns the precise shape of your attention, including all its edges and boundaries. Once TikTok has your behavioral data, it needs to represent you in a form a computer can reason about mathematically. This is where the concept of embeddings becomes central to understanding the whole system. Every video on the platform is mapped to a point in a very high-dimensional vector space, with thousands of dimensions collectively encoding the video's genre, pacing, audio signature, visual style, topic cluster, and emotional register. You as a user are also represented as a vector in that same space, not separately. Specifically, your user vector is computed as the weighted centroid of every video embedding you have meaningfully engaged with over time. The more cooking content you watch to full completion, the more your user vector drifts toward the region of that space occupied by cooking videos. The further you scroll past finance content without pausing, the further your vector pulls away from that region. This recalculation runs continuously after every session, so the mathematical portrait the model holds of you is never static and never fully complete. With user vectors and video vectors defined in the same space, measuring compatibility between you and any candidate video becomes a single mathematical operation called a dot product. Two vectors pointing in similar directions produce a high dot product score. That score is the raw prediction of how likely a given video is to hold your attention. This design is elegant because it means TikTok never needs to explicitly understand or label your preferences in human-readable language. It only needs to compute distances and angles in a space that was learned from the aggregate behavior of 1 billion users accumulating over years of continuous interaction data. The specific technique that powers this at scale is called collaborative filtering via matrix factorization, and it reveals something genuinely counterintuitive about personalization. The algorithm does not learn you directly from first principles. It learns you by finding the users who are mathematically most similar to you and then serving you the content that those users engaged with most deeply. Imagine a giant matrix where every row is a user, every column is a video, and every cell contains an engagement score. That matrix is almost entirely empty, because no individual user has watched more than a tiny fraction of all available videos. Matrix factorization decomposes this sparse matrix into two smaller learned matrices simultaneously, one that places every user in embedding space, and one that places every video in the same space. The learning objective is for the dot products between user and video vectors to reconstruct the known engagement scores so accurately that the model can then reliably predict the unknown ones. The result is a system that infers taste without ever being told explicitly what taste means in human terms. This approach has one well-documented weakness called the cold start problem. A brand new user with no watch history cannot yet be placed meaningfully in embedding space because there is no data to triangulate from. The solution is deliberate diversity injection. New users receive a carefully selected set of high-variance content spanning many topics and emotional registers. Their initial swipe decisions, which videos they stop for versus which they abandon in the first second, are used to place them approximately among existing user clusters. From that rough initial placement, the collaborative filter takes over and rapidly refines the position over the first hour of use. New videos face the same challenge in reverse. Video with 0 prior plays cannot be retrieved by similarity search because it has no engagement history. TikTok solves this by injecting new content into small random user cohorts and using the measured engagement response to decide whether to expand distribution broadly or quietly suppress the video. Before any video reaches your feed, it must pass through a two-stage ranking funnel designed to balance accuracy with the speed requirements of serving a billion users in real time. In the first stage, candidate retrieval, an approximate nearest neighbor search runs across the full video catalog and returns roughly 1,000 videos that are plausibly relevant to you. This stage must complete across hundreds of millions of videos in under 100 milliseconds, so it uses approximate methods that sacrifice a small amount of precision for dramatic speed gains. The second stage is a deep neural ranking model that takes those 1,000 candidates and applies a much richer and more expensive feature set. Your detailed watch history, time of day, device type, creator-follow relationships, video freshness, predicted completion probability, audio features, and dozens of additional contextual signals all flow through the network, which outputs a fine-grained ranked score for each candidate calibrated specifically for you at this exact moment in time. The feed you ultimately see is not the raw top 10 outputs from the neural ranker. Post-ranking layer applies diversity constraints to prevent consecutive videos from the same creator or the same narrow topic. It then applies an exploration budget that deliberately injects content outside your established taste profile. This mechanism is drawn from reinforcement learning and is known as the epsilon greedy strategy. With high probability close to 90%, the system exploits its best current model of you and serves the highest rank prediction. With the remaining probability it explores, serving something genuinely outside your known range, and then measures your reaction with the same millisecond precision it applies to everything else. A skip on an exploration video in under 2 seconds is extremely high-value training signal, so is a full replay. System is continuously running controlled experiments on your attention to discover where your actual taste boundaries sit, not where you believe they sit. What makes this architecture particularly effective at retaining attention over time is the extraordinary speed of the feedback loop it runs. When you watch or skip a video, an event fires immediately into a distributed stream processing system built on infrastructure similar to Apache Kafka. Your user embedding is updated within seconds of the interaction. The neural ranking model is continuously retrained on fresh engagement data in background gradient update jobs that run without interruption. The complete cycle from your action to a meaningful model weight update takes well under 1 second on average end to end. This is architecturally and philosophically different from older recommendation systems that ran nightly batch training cycles and updated recommendations once per day. TikTok's model is alive in a way that prior media systems never were, adapting faster than you can consciously track. Putting the full system together, the picture that emerges is this. Your action fires a stream event. That event updates your entry in the real-time feature store. The updated features drive an approximate nearest neighbor retrieval across the video catalog. The retrieved candidates pass through the deep neural ranker. A diversity and exploration layer reshapes the final slate. Your next videos arrive on your screen in under 200 milliseconds end-to-end from your last swipe. This entire loop runs simultaneously for 1 billion users with no human curator involved in any individual recommendation decision at any point in the pipeline. It is entirely self-organizing, continuously improving on its own predictions, and operating at a scale that has no direct precedent in the history of media or mass communication. That is how TikTok learns your personality, not by reading your mind and not through any single clever trick. By building a precise mathematical portrait of your attention from billions of behavioral signals measured continuously, comparing that portrait against a billion others in high-dimensional space, running a continuous ranking and exploration feedback loop that updates faster than you can consciously perceive, and delivering the result to your screen in under 200 milliseconds. You did not discover your For You page. You trained it one swipe at a time. Thanks for watching.